This is for 3.3, Exponents and Multiplication. So first we are going to look at what this would be. We're going to remember that exponents are a shorthand notation that allows you to write expressions containing repeated multiplication more efficiently and precisely. So like I've told you before, mathematicians don't always like writing things out, so they shortcut stuff. So this right here is 7 squared times 7 to the third. And so we want to know what that means. 7 squared is going to mean 7 times 7. And 7 to the third means 7 times 7 times 7, or 7 3 times. So when we are multiplying them, we want to know how many 7s do we have. Well, really, we have 7 5 different times. So we have 5 factors of 7, which is 7 to the 5th power. So that's what we need to know. Every time that it looks like we are multiplying two bases that have exponents with them, we are going to be adding those exponents. So here is your example, and it doesn't matter if we're talking with numbers or with letters. So let's give it a try. Okay, so here we have 5 to the 2nd power times 5 to the 8th power, and we had said this is going to be 5 twice, and then we have 5 8 more times. And then we want to know how many 5s total. Well, this is 8, and this is 2, so that gives us a total of 10. Here we have x to the 3rd times x to the 5th times x to the 10th. They all have the same base, which is x, so we can just add our exponents. 3 plus 5 plus 10. 3 plus 5 is 8, plus 10 is 18. Then we're going to go ahead and we're going to look at our last one. This one, our bases are not the same. So we have a 2 and a 5 out front, and then we have m to the 10th and m to the 2nd. So we're going to separate them out like that. So we have 2 times 5, which is 10, and we have m to the 10th power and then to the 2nd power. So that's going to give us m to the 12th power because we're going to add those. So we have 10m squared, or to the 12th. Okay, on this one, we're going to have to pay close attention. There we go. This one, we're going to have to pay close attention to where our numbers are as well. So we have a 3 and a 5, and then we have a y to the 4th and a y to the 7th. So we're going to keep them separated. So we have 3 times 5, which is 15. We have y to the 4th and to the 7th, so we're going to add those exponents. So we have y to the 11th. So 15y to the 11th is going to be our answer. So the question is, does x to the 8th times x squared have the same value as x to the 5th times x to the 5th? And we would need to justify our answer, which in mathematical terms just means prove it. So here we have x to the 8th plus times x squared. So we're going to add our exponents right here. So I land at x to the 10th. Here we're going to add our exponents as well. So I have x to the 10th. And these two are going to be equal to each other then. So yes, they do equal each other. Okay, so we have been multiplying powers with the same base. Now we're going to multiply a power of a power is what they're called. So when we first look at it, we have 5 squared and then that to the 3rd power. So what this means is that we have 5 squared 3 different times. So we have 5 squared times 5 squared times 5 squared. And in that case, each 5 squared really means 2 5s. So 5 times 5 times 5 times 5 times 5 times 5. And then we want to know what our total is going to be. In this case, as we're running through it, we're going to see that it is 5 to the 6th power. Okay, because there are 6 5s right there. So as we're seeing that there are 6 5s, now we're going to go ahead and look and see if we can make any connections. We have a 5, which is our base, and then we have the 2 and the 3, which are the exponents. When we multiply them by each other, we're going to land at 6. So when we have a power to a power, then we are going to multiply our exponents. And that is going to be true whether we are doing it with numbers or with letters. So they're just showing you that here. Okay, so let's give it a try. Okay, so here we have 10 to the third times, or to the second power. So that means that we have 10 to the third times 10 to the third. When we're looking at that, this was what we were doing last time, powers with the same base. And so when we put those together, we're going to have 6. Over here, remember, when we have them one on the inside of the parentheses and one on the outside, we're going to multiply. Okay, so we have x to the third to the fourth power. So we're going to multiply our exponents and keep our base the same. So my base is an x. When we multiply those, we're going to have it to the 12th power. A to the 5th power, then that whole amount to the 6th power. We're going to multiply the 5 times the 6, and we're going to get a to the 30th power. Go ahead and try this one on your own. You can pause it. Okay, now that you're back, we're going to have g to the 9th, and then that to the 6th power. When we're looking at that, we're going to multiply the 9 times the 6, so we're going to land at g to the 54th power. Some algebraic expressions containing exponents include several bases or a combination of numbers and variables. So you need to inspect it carefully in order to apply the properties of the exponent successfully. So let's take a quick look. We have 2 times 3 and that whole expression to the third power, which really means that we're going to have 3 of those expressions multiplied by each other. So let's look. Together, that means that we have 3 of them that are 2's and 3 3's, and we're multiplying all of those together. So you can tell here we've taken the base and we've multiplied it to the third power, and then the second base, we've multiplied it to the third power. And then that is going to give us our answers. When we go back to the power of a power, we are looking at these bases, and they really have a power of 1 because everything has a power of 1, every regular number that we're talking about. So if I have 2 to the power of 1, that just means 2 one time. Or if I have 3 to the power of 1, that just means 3 one time. So that's what we have here. So you can really take the 3 times the 1 and the 3 times the other one, and we're going to get 2 to the third power times 3 to the third power. And once again, that's going to be true whether it is with numbers or with letters. So here they're giving you your examples that are both arithmetic and algebraic. Okay, let's give it a try. So we're going to simplify each expression. The first one says 3cd squared. We're going to go ahead and we're going to put the powers on them so that we can see them. So the power here is a 1. The power on the C is a 1. And the power on the D is a 1. So I'm going to go ahead and drop a little 1 on each one. Then I'm going to do 2 times the 1, and I'm going to get 3 squared. 2 times the 1, and I'm going to get c squared, and 2 times the 1, and I'm going to get d squared. When I have 3 squared here, you should know that that is 3 times 3, and so that's going to be 9. And then the c squared and the d squared we can't do anything with, so we're just going to bring them down. Okay, we're going to do the same thing on this one. 5m squared n to the third power, and all of that to the third power. The only base up here that doesn't have an exponent is the 5, so I've gone ahead and dropped in a 1 for that. And now I'm just going to take my 3 and I'm going to distribute it clear across the entire expression. So I have 5, and then I have 1 times 3, which is 3, 3 times 2, which is 6, and 3 times 3, which is 9. And then I'm going to say, what is 5 to the third power? So 5 times 5 is 25. 25 times 5 is 125. So I have 125, m to the 6th, n to the 9th. Go ahead and try this one on your own. I'm going to give you some answer choices so that you can see whether or not you're doing it right. And then I'm going to explain it. Okay, down here I've already given you the correct answer. Let's run through how we got it. So we're going to take the 4 and we're going to multiply it by the 1. So I have 2 to the 4th power now. I have s, and then I'm going to take 5 times 4, which is 20. And I'm going to have t, 4 times 9, which is 36. Then I'm going to take my 2 and multiply it by itself 4 times. And that is going to give me 16, because I have 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. And then I'm going to keep the rest of it just like it is. So I have 16, s to the 20th, t to the 36th. Okay, I hope this makes sense. Make sure you've written down any questions that you have for me so that you can bring them in, and we will talk about them tomorrow. Thank you.